So the problem is jump game 9. It is the ninth problem of the jump game series. What is given here? It is given one integer array nums. So what we can do, we have to jump from one index to another index. At the end, like I'm giving you the summary. I'm coming the jumping condition later. So this is the array. In this array, this is the array. So assume I'm at here at ith index. So I can jump either right side or sorry left side or right side, and what is my expected result after jumping several times. Like I can do this kind of jump, like I can come here, then come to there, and then come to here. This is possible. So after jumping at any number of times, I need the maximum value I can reach after valid jumping. Okay. So this is my I have to return. Okay, so there are conditions for this jumping. So I can jump any index j such that, like, it possible like j is strictly greater than I. So strictly greater than I means j can I can jump to the right side. It is only possible if and only if and only if my nums of j is strictly less than nums of I. And after that, we can do another jump. Like I can jump a j less than I. That means left side of the I. We can jump less than I if and only if my nums of j is strictly greater than my nums of I. So this is the condition of jumping. So if I say in a simple words, what I could say, like I can't at any index position I can jump to right side to any index if and only if my value is lower than my current index position, and I can jump in any index side on the left side of the I if and only if any value of the left side is strictly greater than my current index position, and then only I can jump. Otherwise, not possible. For example, if I had index I and it is 5 here, if the every index is greater than 5, okay, so I cannot jump, because for jumping to the right side, like value should be less than my current index position. Okay, so let's take an example. So first, take this 2 1 3. So 2 1 3. So what will be my answer? Like if I starting from this index position 2, what I can do? I can jump to the right side. I can jump to the right side. So right side, to jump to the right side, what is my condition? So any value should be less than my current index position, that is 2. So here it is any value present that is currently less than my current index position. Yes, 1 is present. So I can jump. So I'm jumping. I'm coming at here. So right now I am at this index position 1. So in this position I can jump again right. So again right is possible. So if it is possible when this value is less than my current index, but here 3 is greater than 9, so I cannot jump to the right side. So can I jump to the left side? Yes, I can jump to the left side, but what is the point of that? Because I am coming from the left side and exactly same index position, right, from 2. So there is no point of jumping to 2 back again. So there is no point as well to jump back to the 1, right? So what will be the answer of this problem? Answer of this current index position is 2. So from 2 I can get maximum value of 2 itself. So this was 1. So whenever I am coming this 1 index position, I cannot jump right side as I told earlier, but I can jump left side. So left side is value is greater than my current position. So I can jump, and that is my maximum value. It is 3. Sorry, 2. And for this last index position, I can jump right side if and only if the value is higher. But here you can see none of the values higher than 3. So it is my 3 will be my value. So this is my answer. This is my answer array or vector. So you can say this is the answer. Now see the next problem. Next problem is 2 3 1. 2 3 1. 2 3 1. So what I can do? So 2 3 1. I am coming at second index position. I can jump to the 1 because this value is lower than my current index position. So I can jump. Actually. I can jump 2 3 1. And after this jump, I can do another jump to 1 to 3, because if I have to jump to the left side, my index position should be right side. Sorry, should be greater than my current value. So I can move to the 3. So here we can see what from 2 we can jump to index at 3. So like we are getting the value of 3, which is greater than 2, and it is the maximum value I can get. From 3, you can simply say from 3 I can jump to 1, and 1 from 3 I can, okay, let me remove this part, and from 3 I can jump to 1. After that, here I can again jump to 3, right? Again jump to 3. But is there any point of like jumping there and again come back to the same place? Is there any point? No point, right? So I shouldn't jump, or it is, even if I jump, it is useless. So it is also 3. From 1, it is simple. From 1, I can only jump 2, or I can jump to 3. So obviously, I will jump the higher value, right? Why should I, if I jumping the right side, why should I jump lower value? I will always, sorry, lower value 2. I will always jump at the higher value. So this is the third index, and this is the maximum I can get. So I am getting 3. So that's why answer is 3, 3, 3. Okay. So these are the examples. Okay. Let let's see one example where we can get all the test cases. So when I am saying I have to jump, so let's say here it is 8. Okay, so from 8 I can jump in which places? I am assuming this is my current index position 8. So if it is 8, what are the my point, like what are the valid places I can jump actually? I can jump 25, I can jump 15, I can jump 10. These are the valid cases like where I can jump. Okay. So, but actually, which place I should jump? I should, because I cannot jump here. I cannot jump here because if you notice, I cannot jump to 21 because 22 is higher. Cannot jump to 35 is higher. I cannot jump 18 is higher. Anything in this right side of the 8, I cannot jump because that is higher. So, but if you notice, my highest element is always the left side. Okay, my highest element is the left side of the 8. So I have to find some way so that I can jump back. So that I can jump here or somewhere, some places so that I can get 35. Okay. So what is my approach? What should be my approach? So what I will do, I will always try to jump at 25, 10 or 15. Which place I jump? I always jump 25. Why? There are two reasons. First reason is that there is possibility like from 25 I cannot jump in 30 places, right? For an example, if 25 is not present, assume 25 is not there. So I can jump either 10 or I can jump either 15. So what, like see here, if I even if I jump at 10 and this 10 I cannot jump in any position, because if I have to jump to the left side, I have to take any smaller value that is lesser than 10. But there is no smaller value lesser than 10. So I cannot jump at the 10 from any other index position from 10. Okay. So even if I go back to 15, is there any possibility? I cannot jump. I cannot jump in any places because all the values are greater than 15. I cannot jump. I can jump to 15 to 10. I can jump 15 to 8. I cannot jump 15 to 1. Does it really make sense? No, right? It doesn't make any sense. It's because if I jump 10 to 15 again, because this is a left hand side bigger value. Okay, so that's why first, this is the first reason I always took the maximum element where I can jump. So I can jump directly in 25, sorry, 50. Or here, my earlier example, it is 25. So I will always jump at 25. This is the reason, first reason, like there is a possibility like I cannot able to jump to the left side. So if that is a possibility, like then if I cannot jump to the left side, that then what is the maximum value? The maximum value will be among this, right? Whatever the among this area, that will be my maximum value, correct? So that's the reason I'm always picking my maximum. I'm picking the maximum value from the left side uh, to jump. This is the first reason. Second reason what? Second reason, if I choose any maximum value, if I choose any maximum value here, any maximum value, then I can jump to any value at least. Like this is the highest possibility I can jump any places. Like for an example, if my area 8, here it is 15. Okay, here it is 25 again. and here it is assume the place are 17, then 35, then it is 14. Okay, if that is the case, if that is the case, now what is the next engine? I should jump to the maximum value so that I can get maximum coverage of smaller value, because yes, see, from this place, from any index I, this place I can jump to any lower value, right? Any, not any specific, I can jump to any lower value. So if I maximizing my this value, that means I am covering to, I can able to jump any lower value, like it will be help me to jump in any places, like from 25 I can jump 14, from 25 I can jump 17. So it will increase the possibility to jump. So because this is the maximum value, so this is the maximum value on the left side, so this increase the possibility to get number of more elements. If I get able to reach this many elements, so there is a more possibility that I will get some higher values, right? For an example, like if I don't take 25, if I get 20, 15, okay, if I get 15, so 15, what are the possibilities? What are the possibilities? Possibilities are, for 15, I can jump to only 14. I cannot jump for to 70, 17 or 34. For this reason, for this reason. So what is the maximum value I can get? I can get 14. Or let's say assume I can, there is another value, let's say it is 30. Okay, so in that 14 I can jump 30. Okay, so this is the highest value I am getting. This is the highest value I am getting. But what are the but if I jump to not 15, the 25, if I jump to 25, so if I jump to 25, 25 gives me at 17, and 17 pull me back at 35. So I'm getting a maximum higher value. If I'm getting a maximum higher value, so that's why I always jump to maximum value of the left side, so that I get the possibility of getting lower values from this higher value. My current higher value is much more than other. I guess you're getting this thing. So an example, like you can say there is another case, like it is 35, this is 30, this is 35, this is 35, and this is 30. This is the another case. So in this case, you can jump any value. Like I can jump 8 to 15, then 15 to 14, and 14 to 35. I can get the 35 higher values. But if the example is previous, so even the 25, if I get 20, 15, 25, 25, I can go 17. Now see this thing. The funny thing is that I can go 25, 25 I can go to 14 directly, or I can go to 17. I'm going to 17. 17 means what? 17. From 17 where I can go any higher value on the left side. From 17 I'm getting 30. So 30, from 30 also I can get what? From 30 also I can 35. Right? So because from here I will say the higher value of the left side, so it is 35. So it is much better, isn't it? So the point I am talking about, like, doesn't matter my what are the left side what is, I will always jump to what are the values present in my right side. My target will be to jump to the higher value of the left side. So that will increase the possibility of getting much low, many lower values compared to the this 25 or current higher value. Okay, I hope you get it. Okay, so this is the one I want to show, like want to tell, like this is the, that's why we'll jump from 25 to, I always jump 25. So what I listen, I need, so what I need actually from this point, what I get, I need, or we need maximum value from left side, left side. So what will help me? So it is nothing but prefix max, prefix max. Okay, understand? So now what are other cases? So I need to calculate a prefix max. So let's calculate the prefix max. So prefix max is like for 15 maximum element is 15. For one maximum element is 15. So prefix max is nothing but I have to iterate from last to first. I have to iterate from last to first, and I have to check what is the maximum value of my current position to my left side. So that is my prefix max. So from first, for this one, my prefix max is 115. For 8, my prefix max is 15. For 10, prefix max is 15. Because this is the, from in this area, this is 15 is the highest value. When I come 25, in this area, 25 is my prefix sum. So 25 becomes my prefix sum. So 8 for it is 25. For 21 is also 25. But 35 prefix sum is 35 only. 18 it is 35. 30 is 35 and 20 is 35. This is my prefix sum. Sorry, prefix not I'm mistakenly saying prefix, it is prefix max. So these are my prefix max. This is a prefix max. So this is what I'm getting. So this is one observation I need. Like I need to find out my maximum value. And what if? Like right now, what are other cases? First, another thing, notice carefully. So if I am currently which is position? Um, I am currently at 8 or 10. 10 is better. Or make it as 10. Make it as 16. 16 or 14 is better. 14 is much better. 14. You understand why 14 I am telling you. Again, if this is the case, this is the 14. Right now, assume this I am currently at this position, at 10th index. Sorry, the 10, second index, 0, 1, 0, 1, 2, sorry, third index. So 10th position, like 10th position is that I am the, in this year, in this third index, okay? So what I can go? I can go where? I can go this place at 15. Now 15, can I go to any other places? Any other places? Is it possible to go any other places? No, right? Because it is possible to go 8 place. But can I? Like, my currently, I will take what? I will take this area, maximum of this area. Then I am trying to get, like, I cannot directly go to left side. Because why I am cannot directly go? Because this is higher than my current index value. Okay. So I cannot directly go to in this place. Where I can go to left side, and from I will try to check from here. Can I go to this side? So from in this left side, I will try to traverse in left side. Can I go to this side? This is my target, right? So can I? So there's a reason, as I told you, from this area I always have to take my maximum value. From the right left side, I have to always take the maximum value so that I can get the number of possibility, like higher number of possibility to get minimum value than this. But even if I am going to leave maximum value of the left side, then also there is no other cases. There is no other cases I can travel. Not here, not here, not here, anywhere, because okay, this I cannot take 14. Let's say it is 16. Yeah, I can go say 14 place, but here now I cannot go any places. Now it is not possible to go any other places because everything is higher than 15. So I cannot go. So the problem is like when I can understand, like I can jump or I cannot jump. What is the cases I can understand? Like if uh, like if my minimum value, what is the requirement to go and check like where I can jump or not, because I have to check like is there any value that is less than my 15, less than my 15. So can I know any other way I can find it out, like is there anything, because I have to check first. I have to check, I'm from here, I have to check this one, then this one, then this one, this one, this one, this one, this one. It will take much time, right? So it will big of in time to check, right? Big of in time to check. So this is not a feasible solution. I need one way so that I can know that can I jump to that place? Can I jump to here or any other places? Is it possibility or not? I need to know like that. Right? Can I jump or not? This is the thing I want to know. So what I actually want to mean to say, like, is there any way I can know, like, is there I can know is a big of one operation I can know, big of one time I can know is that I can jump or not. Think of it. So when I can jump, so this place. So if the lower value at this position is less than my 15, if it is possible, not this position, this position, because if the lower value is this position is less than 15, I can directly jump there, right? or this current place. So if any lower value of this position in this current position is less than my 15 or not. If it is, if I know that thing, then I can directly jump. I can directly jump and go there. Like, okay, there is, I can jump and I can check whether it is a minimum. If it is less than 15, I can jump. Okay, so lower value of and which place, like this place lower value or this place lower value? Obviously this place lower value, because I want to jump at this side from this area, right? I want to jump in this area. So is there any way? Yeah, I can do. I can find the lower value from this. The same way I find out the maximum value at this place, the same way I can find the lower value in this place. That is called suffix sum. Suffix sum. So we need what? We need second thing, like we need we need minimum value minimum value from right side, that is called suffix min. I'm no longer I'm multiple I'm saying suffix sum or prefix sum. Please pardon me. This suffix min. I'm saying suffix min. Suffix min, how can I calculate? So I'm starting from this place, and also I'm taking the only minimum value. I'm checking this value, and this is how I can calculate the suffix min, right? So I can calculate that. So let's calculate. So current index position is 20. So 20, this will 20 will be my current suffix min is 30. Current suffix min is what? 20 only. Like minimum, how to calculate suffix min? I'm iterating here. I can store the minimum value. Then I will come. I'll check like minimum value is less or equals to my current value, or if it is less, then put it, or if the current value is less, then it is actually my current minimum or current suffix minimum. Similarly, it's 18. 18 is the minimum, so it will become 18. 35, 18 is the minimum. 18, 21, 18 is the minimum. From between 21 and 18, 18. So we will suffix some. Sorry, 16. Right now, my minimum is 18. So 16 is right current minimum. Becomes minimum. So 16 here. So 25, 16 here. So 30, 10, 16 here. 8, it becomes 16. Sorry, it becomes 8. Then it becomes 1, and here it will be 1. This is how I can calculate the suffix minimum. Hope you get it. So now you can argue with me, like, why I'm taking I plus 1 this value. I'm checking this value. I will check this value. Why I should not check this value? Let's take an example. For this, I'm not having. We'll have the example. Let's take the example. Why should I check with this value? As I told you, I have to find the minimum of this range, not this range. But you can see here that this range also minimum is same, right? Let's take an example. So this is the example. Take this example. Right now, assume my value is at this position. So what is I can go right as earlier I can go 3 to the 5 maximum value. Then where can I go? So if I take only this place, in this place, it is possible I can come back here only. But I have to go to here in any place right here. So what is the 6? I have to check this one. So this one is greater than my 5. So see, the minimum value of this area is only 6. Only 6. So even if it is 5, even if it is 5, I cannot go because I have to go a place where it is strictly less than. So even if it is 5, even if it is 5, I cannot go directly. I cannot go in this place because where? Because I have to go any place where it is strictly less than my current is 5. I can go to right if value is strictly less than. So if it is 5, I cannot also go. So here I have to check from this area, can I go? Can I go? So for this checking, I need the minimum value of this area. That's why I'm checking what is my index position. I am checking I plus 1 index position. I hope you get it. So this is why I am checking I plus 1 index position. So that's why. So one thing I know, like if now see this is the case, if at this index position I can go right side. I can find the maximum value of the right side. I can go there, and after that I know, like, I can't go to the left side. I can't visit the left side. So after my iteration, if I am assured like I can't go the right side, I can't go the right side. So then what is the maximum value? The maximum value will be maximum of this left side. So at this index position, the maximum value will be what? The maximum value I can get, that will be the maximum value of this range. That is nothing but my prefix sum, sorry, prefix max of this index. Nothing but the nothing like the prefix max, right? So I can write. Let me write that condition. So what I am saying about, what I am getting, if, so I will always have the if my prefix max. So I can get my prefix max, right? Prefix max, prefix max, or I can say current maximum well, current max well. So maxwell, current maxwell. I told you like nothing but I will like I am why I'm taking current maxwell equals to prefix max, prefix max of I. Why I'm saying taking that, because see this one. I can. There are possible like from 16 or it is 20 and if I am 21, there are possibility I can go to 20, 18. I can go to here. Here I can go to 25. But why I am choosing this value? I can go to 18 also, right? And then I can get 35. Okay, I'll come this later. For this case, I am saying this thing like why I can get maximum value. Like if there are two cases, I can go there. I cannot also go that place. I can only move this place. I can only move this place. This condition will come. So as like here only, here you can see I cannot move to what I can say that right side. I cannot move right side. So I can only move the left side. From this is the case. First case. There are three cases. Three cases are there. I we can move. We can move both side, like both side. We can move only right side. Only right side. So and we can move. We can move only left side. These are the three cases. Right now I'm talking about these third cases. We can move only the left side. So if that is the case, if that is the case, what are the my cases I am talking about? So the thing is 15. So there's a reason I am talking about the last third case. This is the case. If this is the case, I can. What is the maximum element? The maximum element will be maximum of this. Maximum of this. Okay, so that's why I calculate the prefix sum. I can directly the current move is prefix sum, and now obviously I have to check like can I move this side or not. So to check this thing, I have to check whether is the meaning of x is this element. Okay, so I will check if my Maxwell current Maxwell is greater is sorry is less than or equals to less than or equal to my suffix mean of I plus 1. If so, that is the set I am talking about. Like if this value is is minimum of this value, so this is assuredly I cannot move this side because from right in the right I cannot go to any greater number. That's why I am checking this. If this is the case, I plus 1. If this is the case, then my answer of I is what? Answer of I is nothing but my prefix sum, prefix max of I, or we can directly assign to this current max one. So there is a thing to understand. So this variable is redundant. So I'm removing this variable and I'm using prefix directly check with the prefix max. Directly check with the prefix max. Hope you get it. Hope you get it what I'm talking about. Why I choose this one. So now see, let's see what is the cases when I can't move to the right side. Okay. Let's take an example where I can't move to the left side. Okay, if you check this one, is there anything like left side? I have to be greater. Okay, so this is the case. So consider this is my I. This is my, if this is the I, on left side I cannot go to the smaller number. I cannot go to the smaller number. Okay. So what I can do, I cannot go to the smaller number. So this place I cannot visit. This is not possible. So in that case, what I can go, let's see what are the out possible ways I can go. I can reach from 25. I can go where? I can go the minimum value is 18. So 18 will tell me what? 18 will tell me go to 25, 35, go to 35. So you can say I can go to 25 to 21. Now 21 will say I am the maximum. You cannot go. If I come to 25 as well. So here, see if it is 18, so I coming 18, 18 will say, okay, don't come to me, come go to 35. This is my base value. So you can take my base value. So what is the case I am talking about? When I am checking up the left right side, I can go to any place, and any place means like any place means that is the smaller value than of this current position. I can go to any place. After that, I can take that base value. Correct? I come here and I can take the base value of at 18 and this at this position. 18 will say my base value is 35. So take my base value. Okay, fine. Even if I go in different place, even if I go at different place at 21, 21 will say, okay, don't come to me. Go to at go to 20 will say I will go also at 18 because 18 is the minimum value. From 18 I will again come to 35. Okay. So 8 from if I go to 21, 21 also forward to 18, 18 will come back to 35. So again I am putting 35. So from this point, what I can assume like to check to the left side, I need a this value should be computed first. So before I can compute this value, I should compute this value first. Then only I can get this maximum value. Otherwise, I can't get that. Got it? So now let's take an example, and one critical example. Like if 18 and 21 is square, 18 and 21 is swapped. Now there is a problem. Now there is a problem. So see this. If I go to 25 to 21, then I can reach 35. This is possible. But if I go to 25 to 18, 18 will say what? 18 will say, hey boy, I am the maximum. Like I cannot go to the right side because all the event of the right side is greater than me. So right now I am the biggest person you can achieve from the left side. But that is not the truth. Like 35 is the also biggest person, but 18 says, hey, I cannot reach the 35. I can, but here, see here. But if I come to 18 this time, so that time 15 is available. I can go to 15, or I can go to 8 or 10 or anything, right? So, but the problem is from 15 I can go anywhere. From 15 I can go no, cannot go on this side. This is not possible, right? This is not possible. So this is a useless thing. So what can I understand? So from here, if my I cannot move to the my left side, then I have to right side. From right side, what I have to check, I have to go to this 21 position. But 21 should be pre-calculated. Should be pre-calculated. So better we start calculating from right to left because there's some example it is possible like 21 is also I need from 21 I need this body because this 20 is less than 21 so I need this body so to be calculated so I need this one is to be calculated then it may possible this is I need this guy. It is need to be calculated. This needs to be calculated. This thing is I need that. Okay. And for an example, like assume these are not present. 15, 1, 8, and 10. This doesn't exist. Okay. Consider this doesn't exist. So in this time, what will be the value of this guy? So 20, then 25 have two options. It can either go to 18 or 21, right? Since 25 have two options, it can go to either 21 or 18. Two options are there, this one and this one. So if I choose this one, I cannot get a maximum value. But if I choose this one, I can come back at 35 and I get like a valid answer. Correct. So what I am getting, I am saying like every time you try to move left to right, sorry, right to left, try to find the value of right to left. So that will be easy for you to get the value. So if assume I have already calculated 18's value. So if assume I calculated 18's value. So from 18 can I get 35? 18 can I get 35? Check that. So what are the cases? So 18, can I get 35? 18 is here, right? Can I get 35? So 18, I can I cannot directly move here. I cannot directly move here. This path is not present because you can see like from here also you can understand my prefix. From here I have to go there, so I have to check my prefix value. So prefix value is 18, so minimum is 18. So 18 said I am the minimum from my right side. So from my right side I am the minimum, so I cannot go to the right side. I have to find any minimum value less than, so this is not possible. So here I can go to any other places, right? So that's why I can come where I can come back to 25. From 25 we are right now. I have only one option right now because 25 I can do 21 because to 18 I have already visited because I am coming from 18, right? But 21 I have two options as well, like 16 also and 21 also. Okay. So even if I come 16, 16 I'm coming later, 21 I can, 21 to 35 I can calculate. So from 18 I can get 35 values. 35, right? So this is one case. So what I'm saying about, I have to always calculate from left to right. If I calculate left to right, I can always get my this value, and I can simply put this one. Like this is the case where we can see like we have to from left to so right to left I have to traverse, and I can take the this value, that answer of this value. Why I am saying that? Because we can directly assign the value of I plus 1. See this one. Here I am getting like what is the maximum value? Here I am getting like if I reach any maximum value of this point, I can take this value, right? Because see this, you have to understand this very carefully. Assume this is my eye. Okay, this is my eye. From this is my eye, can I take maximum value of this one? If this is not the case, if this is not the case, can I take the maximum value of this one? Why I am taking the maximum value of this one? So maximum value of this one means I can, that means from here I can reach one maximum value and one maximum value in any places, right? From so I don't know how can I calculate this one. Forget how can I calculate this one. Why I can take this value. Think of this first. Forget how I calculate the maximum value of this I plus 1 index. Just think why I can take the value. And then I will think of this, how can I calculate this 18? Why can I take the value? Because somehow this guy is calculated, check this his left side, check his right side, and came to know somehow. I don't know how, but somehow it came 35. 35. Okay. So if that is a 35, that is the case, and then 35 is the maximum, right? So from anywhere in any place, 35 is the maximum I can get. Now 16, I am at 16. I am at 16. 16 do can what? 16 do. So as I told you, 16 go, always check from the left side what is the maximum value. And from maximum value, it will check whether can I more go to the my right side. Can I go to the right side? So it will check this check. Is if else statement check. If it will check this statement, and from here it can understand, yes, I can obviously go there. So why to calculate this value? Because I can, if is the case, and if I go there, so obviously if I go this side, doesn't matter where I go, so this value I can go any place. Here I can go, here I can go any place, right? So any place, this place will leads to me this 30, this maximum value of 18. Why I am saying that? So this 16, so 16 is coming here, right? 16 from 25, 16 to 25 I can go, and that from 25 I can go again at 21 or 18 or this 20 value I can go there. So let's take one by one. So if I get 25 and if I go to 20, 20 will say don't come to me, go to 35 because this is my base 12. Okay, so I am getting 35. And what is the answer of 18? Answer of 18 minimum is 35. Let's say I am told you not. Let's forget about how 18 is calculating. But think why I am taking for ith place. Why I am taking I plus one's answer. So 35 is the value of 18. Like maximum value I can reach from 18. Okay. So from 16 I go 25. 25 go to 20, and 20 I can go directly jump to 35. So I can reach it. So what are the other places I can go from 25? The 25 other classes means like that's why I told you like I should have start calculation from right to left. You know, you understand right now why. So right now 25, from 25 where I can go? I can go to directly 30, not 30, 21. 21 I can go. 21 again sir, go to 35. Okay, fine. I can go 35. So what are other places I can go? So 25 to 18 I can go. So 18 I have already calculated, that is 35. From 18 I can say go to 25, and 25 to 21 and 35 same places. Like that's why this is how I calculated 20 18. But for I told you forgot how I calculated 18. So I know I can get 18, and from 18 I can get 35. So 25 I can go 18, and 18 is pre-calculated, that is 35 I can get. So I can directly take 18's answer. Okay. This is the one example. Let's take this 16 is not there. This is 14. The same thing. This is 14 can go 25 as I told. So now 14 has another option. For 18, 14 can go 20, 15. Okay. From 15 it cannot go anywhere. 15 it cannot go anywhere. Okay. So they are the my limitations. Okay. So the thing is, that's the reason I told you how I calculate. I obviously calculated my is 18. So the thing I am telling about, if I go to right side and this from this value, if I can traverse my current, if I can traverse my current index left side of my right side of my current index, then I will always take this value, because even if I go any place, it will always put me back at the current place. Okay, like put me back the right value, like maximum value. It doesn't matter. I can give you this walkthrough. I will take multiple example and give you the walkthrough. So, so let's see. I'm coming. I'm as it were. I'll calculate from left to right. So I'm calculating from this place. This place. I'm calculate from this place. So 20. So now there is a special case. Is 20. What will be the maximum value of this 20? 20 maximum value will be maximum of entire array. The maximum value I can reach from the last element, it will be maximum of entire array. That is the nothing but prefix max. So I am talking, this is 35. So answer of this is 35. Hope you get it, 35. This is the answer of 20. Now I am coming to 30. How can I calculate the value of 30? From 30, I can go any place here, here, here. So what are the options? I can go always. I will initialize with check this thing. I will try to move to the left side maximum value, because it is easy to understand, easy to get maximum value. My target is what? Getting the maximum value, and getting the maximum value from the left side I can easily get from this prefix max. That's why I am always starting this starting my initializing the value, checking the value from my left side, because I can go to the maximum value in this place. This is a very fast example I taken. Like that's why I told you why should I go to the maximum value of the left side, so that I can reach I can maximize the possibility to go to the left side as well. So currently I am I is right now is 30. I can go to 35, and obviously from 35 from left side I can go 20, but 20 I am already get 20 I have already taken, my max value is 35. So this is also 35. 20 saying like from me, you can get a maximum value of 35. I have already visited all the possible cases. So this is fine. So now I am moving my I to 21. I to 21. From 21, where can I go? I can go 35 again. And 35 again, I can go to 20, is left side. And from 20, I already got the answer. I know what is the value of 20, that is 35. So that's why. There's the reason I'm taking I plus 1. So why I plus 1? So think it is not going to 30, 20. It will can go to 30, right? And 30 always say, okay, I already got the value, it's 35. So I'm actually taking 30, like I plus 1, the value of answer of this plus this one. So that's why I'm taking the value. So this is an observation you can understand. So so again I come to 35 position. I come to 35 position. This is the observation. 35 where I can go. So from left side, I'm told you like I have to taking the maximum value. Maximum value is nothing but 35. I know this is a 35. I will get 35. Okay, but 35 I'm getting. So 35. Please don't look at this thing because I have changed multiple times. So according to that, this suffix main will change. Okay. So if I change right now my account right link, so right now notice like I change this one. So it will be 14 14. So it will be 10 here and 14 here, 14 here, and I get the rest of the same. So one more time. So okay. So if I 35, I cannot go to the left side because nothing is less than 35. So sorry, greater than 35. So I cannot go, but I can go right side. So right side there are three options: this. So I can go any place. This will point to my 35. So what is the easiest path I can go get it? I can check this one only, the right side. So I say go by 30. Go to the 35. It will say go. You are the only one who is maximum. So take yourself. So I'm taking this thing as 35. Now I'm taking as 18, coming to 18. 18 I'm coming as 18. From 18 where can I go? From 18 I can go to where? I can go to 25, right? I can say maximum is 25. 25 I can go. From 25 I can go two places, like 21 and 20. Both I have calculated, both are 35. And surprisingly, that is the value of I plus 12, 35. So why should I rotate? I can directly take 35 right here. So 35 I can take 35. So that is the list. So I comes at 14. From 14 where I can go, where are the places I can go? For places I can go 25, I will go to 25. 25 again, it will go to 18, it can go 21, it can go 20. So all the places, it will give me the value of 35. This is nothing but my value of I plus 1. So answer of I plus 1, 35. From 25, where can I get? From 25 also. So from 25, where can I go? From 25, I can go. I can see maximum is 25. So I cannot go to any place to the my left. So I can go here and directly again 14. I can check 14, 18, 21, 30, 20. For every case, answer is 35. Surprisingly, this is my I plus 1 12. So for 25 also, I am taking 35. Okay. But now the example comes to the 10. Now I comes at this position 10. I is 10. So if I is 10, where I can go? I can go directly 15. 15 I can go. Now from 15 can I go some places? From 15 can I go some places? Yes, 15 I can go 14. 15 I can go 14 and the value will be 35. Okay. So I can let's assume I don't go to 14. Let's move to my actual place that is 16. Make it value as 16. This is also 16. Yeah, this is 16. So this is a 16 value. So if you calculate the same way, like it will be the same, it will not change anything. But for this thing, it will change. For 10, I can go to 15. For 15, I cannot. I check this condition. Can I go to my left side, right side? I can't go my right side because maximum minimum value is 16. That is my uh, greater than my current value. So I cannot go. So I have to take maximum value of this. So it's maximum value is 50. Okay. For 8, what is the maximum value of the 50, 15, I can go 15, and 15, I can go 10. So 10 is giving me the value of 15. So surprisingly, it is only I plus 1. Like it is I plus 1, like value of answer of I plus 1 is 15. Similarly, if you come here from 15 and 15 from here, you can get 15. So this is the thing I want to tell. Like this is so if this is the case, like if I can go to left side and from left side I can go to right side, then this will be my if I sorry if I go to left side and from left side if I can go to right side, then answer will be different. But if I go to the left side and from the left side I cannot go to the right side, in that case my answer will be this one, my prefix max. Otherwise, if I can go, that means else part, like from this is the case, I cannot go. This is the case. We can't. This is the case. We can't go left to right. It is not possible. Else, if it's possible, I'll simply taking what? Else, I'm simply taking what? Answer equals to answer plus 1. This is nothing but an observation. So otherwise, you have to do what? Answer plus 1. It's an observation. Why I'm doing this observation? Otherwise, you have to do a recursion. Like here, like as I told, whenever I 18, I can go 25. 20, I have to do recursion. I can go 20, and then I have to check 21, and then I can 18. These three cases I have to check, and it will return me the maximum value. Then I have to take the maximum value. This is a recursion. It will take time exponential time complexity, right? I have to check these three, this one, and this one. This is how we can get like this. So, but instead I can get anything like I am getting I plus 1 value. So I can directly put it to I plus 1. So this is the value I can minimize my time complexity. So let's take this example. I told you I will take multiple example to explain this thing. So currently, let's start. I will always start from 8. So 8 I told you what will be my let's take the below. Okay, from 8 what I can say, I start from the right side. So this for this one obviously my maximum value from my left side will be the answer. That is nothing but 10. So this is the 10. So 9 is here. So 9 is here. So 9 I can go left side. So left side I will go maximum value. So maximum value 10. 10 I will get 8. So you can see it. Like what I am actually getting my answer of my I plus 1 index. So I is also 10. I is also 10. So right now I'm coming at 10. From 10 I cannot go this place because if I see the prefix max, this is my 10. So I cannot go to the left. So I can go to here. From now if I check, look this thing. There are two possibilities from 10. 10 to 8, 10 to 9, right? So this is nothing but I have to do a recursion and check like from 8 what can value I get. Then I take the value of 9. Then I have to maximize like take the maximum value. Inside I can see like both of them are 10. So I am getting 10. That is the maximum value I am getting. So I take 10. Similarly, like if I get 7, at the 7, in this 7, that is the value of 7. 7 I cannot go to left side because 7 is the maximum. From 7 can I go to right side? Uh, 7 can I go to my right side? No, right. I cannot go to my right side as well. So as I told you earlier, so this is the check I have to do. This is the check we have to do always. So prefix sum, copy this prefix sum. So I cannot go to left side. I cannot go to right side as well. Because left side all values are lower, right side all values are greater than that. So my value will be what? This is the case. Like prefix sum is I. The prefix sum is what? 7, 7 itself. And I cannot this is also less or equals to my suffix min plus equals to 1. So this is the case. If this is the case, prefix sum is the answer. So this thing is means that I am the like he's saying like I am the person who is the answer. 10. So if you calculate this same thing for this 10 as well, prefix mass is what 10. Okay. And suffix mean I can go to suffix means actually. So here I can go and check some value. So let's say go to the 5. 5 what I can go. 5 again 5 is where 5 I am here. My prefix max is 5. So I cannot go this side. This is one of possible. This equals to. So I cannot go here. Even though I cannot go left side as well. Because on left side there is no small places. In that case, my suffix min equals to like my output of this value will be 10. Sorry 5. And it is not 10. Why I am saying 10? It is 7. Its own self. So there are two cases. You can check like what is the I'll check my prefix max is something I can become the prefix max, so that's the prefix max is 5 itself, and it will check like suffix min will check like this is the case I plus 1 suffix min will check this one like can I go to left side. Suffix min will tell you like can you go to the right side or not. Suffix min will allow you to go to right side. Prefix max said Like from here you can get maximum from start to end. Now from there you can go to left side or not or not. This is what prefix max says. Prefix max says prefix max gives you the number which is the maximum from your left side. Now suffix mix is the person who will tell you, like suffix mix is the person who will tell you, are you allowed to iterate your right side or not. This is what suffix means. The prefix max gives you that thing, like it gives you 5, and suffix means saying like are we allowed? So for this allow, like it should be greater than this prefix mean of I plus 1 should be greater than sorry should be less than my this one. So this is not the case. So that's why this is the answer for 3. What 3 what I can check. For 3 can I go I can go to left side. Prefix 1 give you 5, so you can go from 3. Prefix mean is what? Prefix mean is 5 as well. Like minimum is 5. From this 5 I cannot go to 5. Right. From this 5 I cannot go to the 5. So in that case as well, my maximum is 5 I can get from here. So I will give my maximum is 5. Okay, now here that 4 I can again maximum with 5. I can go 5 here, I can go 5. Now 5 from here I can go 5. So prefix max, let remove this part. You can, with example, this is a special case in the sense come here 4 I can get prefix max. Now the suffix mean is 5 is greater than my suffix mean I plus 1, right? So in this case I can allow to travel this place. But why to travel? I can directly get, like even though I go 5, I can go 3. This is the place I can get 3. So there's a reason I can answer equals to answer I plus 1. So I will take this answer of this place. So it will get third. Sorry, it will give me 5. Answer of I plus 1. That is nothing but 5. So 5 is the again the case. Like I come back to 5. 5 I can give what? From 5 my prefix max is 5. I can go 3. So like I can iterate my right side. I can iterate my right side, and that is the case. I can iterate the right side. That is the case. I can go 3. 3 gives me 5. So you can see this is my answer plus I plus 1. So I can simply get my answer from I plus 1. So the thing is, it doesn't matter where I go. Like I can go here, it will put me back at 5. So this is I can go here as well. That it will also put me with 5 or this 5 something. Okay. So somehow my if I can traverse my right side, if I can traverse my right side, so somehow I can get my answer from my previously calculated thing. That's why this is also my 5. So this is the answer of this. This is how we calculate this. This is the main logic actually. This is the main logic of this problem. So the intuition behind this problem is like I will stand one point, I will stay in a point, one index place, any index place. I will try to calculate, I will check what is the maximum value I can get, right? So intuition is like that. I want to always get the maximum value. That is my target. I am greedy. I need a maximum value. So from left side, can I get maximum value? Yes, that is already calculated. That prefix max. So I can get maximum value from right side, left side. Now, can I get maximum value from the what is called from left side? Can I get the maximum value? Maximum value is 10 here. Can I get the 10? Is it possibility? That I need to check. That I need to check. I can get it if and only if I can traverse. I can traverse from my. I can traverse to the right side. For traversing, can I traverse directly? Like 5 to 10, I can I traverse directly? No, right? I have to go any small, like any value, and from that value, from any value from my left side, and from that value, I have to traverse to the right side. So, another the catch is like I can traverse to the left side only if the value is greater than me. So, if I go to the left side and get a value is greater than me, so I go that value, and from that value, I have to find a point where I can go from the right side. I get a value which is less than my current value. Current value means this one. This one is this value. So I can go to that value and check that right side. Okay. So this is the intuition. So intuition is the most of the cases I will take the maximum value from the right side because the easiest thing I can get from my prefix max, and then I will try to go to my right side and check whether I can get the maximum value or not. So simply for this example as well, let's walk through, like give you the final summary of this. For last index, I can easily get the maximum value by the maximum of this entire array. That is nothing but the prefix max of this index position. Okay. From this onwards, I have to check what I have to take the maximum value of this side. That is 15. This is what is the maximum value of this left side, and I will take this. And from this maximum value of the left side, I have to find the minimum value from that, so of the current index position. What I am saying, I have to calculate. So uh, calculate maximum from left, and let that is x. I have to calculate minimum, some minimum point, that is for which that some minimum, let's say y. This y is actually less than x, like x is greater than y. This is a sample, like that's what that is the case. I can go left first, then I can jump to the right and check what is the maximum value. Similarly, the 30, we can take the maximum 35, and 35 I can go to 20, and 20 gives you 35. So you can see, like, this is one thing I'm always getting, like always I'm getting, like in anyhow in any place I can jump, any place where it doesn't matter where I go, it will leads to my uh, the answer of my I plus 1. Like here I can go try to 35, I can go come back 20, and 20 gives me 35. So this is nothing I plus 1. So 21, let's come at 21. 21 I can go maximum of the left side 35. 35 now have two options. It can go 30 either, or it can go 20. So it has two options, either 30 or 20. So in this case, so both of them we are given 35. So this is what I am saying is, I am observing, like, somehow my I plus 1 index is giving what is the value of I plus 7 index, or what is the answer of I plus 7 index. That is the case of my when I can traverse from left to right. If I can traverse from left to right, then my I plus 1 value is my current answer. The answer of I plus 1 is also my answer. If I can't traverse from left to right, in that case, my maximum value of my left side will be my current answer. This is the intuition of this problem. Okay, it is very confusing, but try to dry run, and then it will be clear to you. You will not understand by seeing or viewing these problems. Try to do the dry run, then only it will be clear. So what I am doing? Let's write the pseudocode. So I need in, and go to nums.length. After that, I told you I need prefix max and suffix min. So for that I need two array of prefix max of size n, prefix max of size n size n, and let's initialize as 0. It doesn't matter which value we initialize, it will be changed later, or it matters actually. Prefix max I'm initializing is 0. For minimum we initialize is some higher value. Okay, and I need a suffix min also. Suffix min suffix min of size n, that is initially is infinity. Actually, no need to do this thing, because the thing, you don't have to do. You can initialize any value at why I am saying that. Because see, this is the array. If this is the array, so 5, 2, 1, whatever the value are. Let's say it is 6. So prefix max for this one, maximum value will be 5, right? So it is the maximum value. And for this value, maximum value will be either my ith index or my previous of ith index, I minus 1. Maximum of this. And the for suffix min, this is the minimum value, 6. And for this place, the answer will be my current index I or the minimum or I minus 1, what will be the minimum, so will be the suffix. So it doesn't matter what you how you initialize. So it is up to you. So but the thing is, I have to say like my prefix max of 0. As I told you, this is nothing but my nums of 0, nums of 0, and my suffix min of last of suffix min will be my nums of n minus. After that, I have to calculate the prefix max and suffix min. So for that, I have to iterate uh, for I equals to 0 to I. So I no need to iterate from I 0 because I have already taken the first prefix max. So starting from index 1 to n and I plus plus. I'm doing what? I'll do simply one line. Line will be my prefix max of I will be nothing but maximum of prefix max of I minus 1, like previous max, or my current value, nums of I, nums of I. This is the case. So after that, another loop will be there. So for suffix min, for I equals to n minus 2, because I have already calculated n minus 1, I greater than 0 greater equals to 0, I plus plus, I minus minus, sorry, I minus minus. So it is nothing but suffix suffix min is nothing but suffix means of I equals to minimum of suffix min of what? I plus 1, previous suffix min, and comma I, nums of I. This is my suffix min. I calculated. So now I have to do what? I have to iterate each and every item. So uh, for I equals to 0, or I need an answer array as well. Like write answer array. Answer equals to array of size n, I'm saying, array of size n. Okay. So for that I would need that. So what I have to do, I have to iterate for I equals to 0, I less than n, I plus, or as I told you earlier as well, like two things I have to do. First, I have to know my answer of n minus 1. So answer of n minus 1 is nothing but my prefix max of n minus 1, and now I have to iterate to each and every element. So for I starting from n minus 2, I greater equals to 0, I minus minus. So what I have to write it here, that case, this one, this is the check I have to do. So if my prefix max of I plus 1 is, copy and I will directly paste it here. This is the thing I have to check. If my prefix max I is suffix less than suffix, that means if it is the case, my answer will be prefix max of I. Otherwise, if it is not the case, then it will be answer plus 1. So this is where it ends. So at the end, return answer. So this is the loop ends and return answer. Okay. So this is the condition. Let's see the time complexity and the space complexity of this problem. So time complexity is nothing but, you can say this is big of n, big of f, n, big of n. So what I'm saying, this is big of n, it is big of n, and this is big of n. So time complexity is nothing but big of n. And space complexity, I am taking an answer array, so that is also n. I am taking prefix and suffix array, that is also length of n, that is also big of n. So can I optimize this thing? Actually, the thing is, we can't optimize the time space complexity. Time complexity is already optimized, is big of n, but space complexity we can't optimize. But here we can reduce these things, this one and this one. I can reduce these two array. How could we do array? Well, every time I need what? I need minimum value, right? Minimum suffix min. Suffix mix, I told you. Suffix min. So minimum. This is just an observation. See what? I come back here. So I need what? Suffix min, right? Suffix min is nothing but I'm iterating from left to right, sorry, right to left. So I can take this one and know this is the minimum. And after that, I can, whenever I'm in this position, instead of maintaining array, I can maintain an index I, like a suffix and a current min. Let's say it is a suffix min. Suffix min is what? Minimum for this one and this one. What is the minimum? I will take this minimum. That becomes my suffix min, right? And answer is nothing but if the thing is, as I told you, if I can't rotate, if I can't can't go to left to right, the prefix max is the answer. So this is the prefix max. If I can go, then I can replace the value. I can replace the value with the uh, answer plus I. Like this is the thing, I can replace the value. So hope you are getting, like, most, like, some of the thing are part of my answer. See here, this entire series is already present in the prefix max. Then here also, this is also my part of the prefix max. Like, see this thing. This example is taking everything the same as the prefix max. So similar to the prefix max. So let's take this one. Here if you can say these, let's say what are the common, what are the things are common here. So this 15 is my actual answer. After this 25 is actual answer. This 35 is my actual answer. So this is like some of the things already common. So other things, other place I can replace, right? Other thing I can replace by answer plus 1. So if you just want to somewhat minimize the thing, you can write the same thing. I'm taking the same code, but the prefix max you have to also take this one. I have to calculate. There is no other way. Let's copy. Uh, Paste it here. Okay. So the thing is, I don't need this one. So what I told you, I don't need suffix sum. I can find a way to calculate my suffix sum. Let me show you how. And the suffix mean is not required. Suffix mean is not required, actually, not suffix sum. This is also not required. And answer is also not required. Let me show you how. These are the steps. This is not required. Let me take the space. Let me edit this thing and let me just replace that place. Then I will start the video again. So same way, just organize the lines. So here what to do, I'm using prefix max as my answer array. So I'll do what? I'll simply change my prefix max is in -1. It is by default in -1. So I don't need to touch by prefix max here. So right now I need the suffix min because here see this place. In this place I am using suffix min. And suffix means I can calculate actually. Suffix min is let's say current min, or let me write it as suffix min as number. Suffix min is nothing but my minimum of current min, like minimum of this number, like nums of I and nums of I plus 1. This is a suffix min, I plus 1. So I need this one, right? I need this one because as I am iterating from right to left, it is easy to store thing, because see I'm iterating right to left, and everything I can get the current minimum, like see here. So I right now I need this one. So I now need these three places. I'm at this next position. I need this one or this one. What are the minimum I need to take there? So I don't need to take look at these places. But you can say for the suffix max as well. When I'm this one, I have to need only this one. But I'm traversing from right to left, right? So it is not possible to get the value. So somehow I need to store the prefix max. But the suffix min I can omit. I can remove the array. I can store this. So that's why suffix min is nothing but nums of I and I plus 1. Okay. And after that, I don't need to give an array. I can simply write suffix min. And in the answer, in every places of answer, I have to write prefix max of I. It is already the case, prefix max of the I. So this is my prefix max of I, and this is also my prefix max of I. So what is the case? What you can notice here, so here actually this should also becomes prefix max. So I'll remove some of the part. I will write again because prefix max of I. Okay, so I plus, not I plus 1, I plus 1, and return prefix max. Return prefix max. Okay, but the thing is, I cannot calculate the suffix min at this place. I have to calculate the end, because what, say this one, suffix min is required. See, whenever I am here, suffix min I need this place. If I calculate fast, then 5 becomes 5, right? 5, it becomes, suffix min becomes 5. But I need to check prefix sum with suffix min plus 1. So as I am not carrying the like array, so that's why I have to calculate suffix min. I have to compare the previous element suffix min. But the thing is that I don't have that. I didn't store the thing, so I have to logic it this way. Like when I am at this place, I know my previous suffix sum is like n minus 1. So when I'm on this place, I know the suffix min will be this one, like this one, right? So I have to calculate. So whatever, then I have to, like, when I am this place, suffix min is this one. But whenever I am this place, suffix min is between this one and this one. So before going that place, I'll update the suffix min as minimum of current number and previous suffix min. Correct. So this is, you have to edit in this place. So what I have to edit? I have to edit like suffix min here. Suffix min. I have to initialize the suffix min, what is called n minus 1 as, so sorry, not n minus 1, this is suffix min, there is no array. So I have to initialize the suffix min as n minus 1, nums of n minus 1 equals to nums of n minus 1. And this step I don't need it. This step right now I don't need this. I'll write at the end of the loop. But the thing you notice, this is a useless thing. Like prefix min and initializing like value. I'm assigning the value prefix max of I with the same prefix max of I. So it is useless. So I can remove this if condition. This remove if condition. This one. I remove this one. Right. After that, I just need what? I just need to check whether it is greater than or not. If it is greater than, then I can directly use this condition, like this else condition. I can directly use that. So this is actually not required. The time complexity will be the exactly same, and space complexity will be somehow optimized, but not exactly optimized. So this would be my prefix max of I equals to my prefix max of I plus 1, because I plus 1 is already changed. And after that I told you I have to do this the suffix main here. So suffix main I have to update the main before that loops end. Minimum of nums of I is nums of I comma and current suffix main. So this is what, and this is all. And I can return my answer is not returned. I can return my prefix max. So I can directly stop this, like loop is end, and I can return prefix max. So the thing is, time complexity will be exactly some big of n, because this is taking big of n time. This is big of n time. This is big of n time. But the space complexity is also saying big of n, because I am taking an extra array. It doesn't matter I am taking this for answer array or something, but I'm taking an extra array of a size n, right? Size n. So this is the extra array I'm taking. But earlier it is taking m3n. Right now I'm using only a single n. So the space complexity somehow it is improved. That's all. Nothing else. Okay. Okay then. I know this video is too much. It is totally confusing, but you have to only understand how to dry run this, and then you can understand why this is happening. And as well as if you find any mistake, then please let me know so I can rectify. And if you find anything useful on the same topic, this is a very tough topic. Not tough, but it's a confusing topic. And also please let me know, and I will also understand the new approach if there it is any. Okay then, thank you. Bye bye.